So now I want to talk a little bit about fiber cable construction. And it depends what the fiber cable is going to be used for. Right now we're going to look at what would be considered an inside building cable. Okay. You've got the fiber core, which is the light carrying member of the glass. You've got the cladding, which confines the light to the core. They're not separable, they're manufactured as a single unit. Next you apply to it a coating. Okay, and that coating goes out to a diameter of 250 microns. Anybody know what the purpose of the coating is? No, the cladding does that. Cladding does that job. Protection, partially, yes. Partial of it is protection. But now think about it. It's glass. Is glass brittle?
Breakage.
Breakage is a good one. Okay, so
and also bending.
It allows you to bend the fiber. That's what I'm looking for. The coating actually makes the glass flexible. Okay, it allows you to be able to work with it and bend it in a certain way without actually having to snap it every time you move it. Right? Because the core and the cladding just untreated like that would break when you moved it. The coating actually gives it flexibility. Next, we add a buffer around that coating out to a diameter of 900 microns. And again, this is on in-building cable. What that does is it provides an additional layer of protection and it makes it easier for us to work with. Then, depending on the cable design, it may have strength members, which are usually Kevlar and aramid yarn. Okay? And then we'll have an outer jacket. And the material that makes up that jacket is kind of dependent on what the cable is going to be used for, whether it's plenum rated or riser rated or whatever. That's typical construction for inside building cables. But I want to show you two different things here as far as buffer types and how cables are actually used. If I use that tight buffered 900 micron fiber where I've got the core, the cladding, the coating, and then that 900 micron buffer, if I use that in an outside plant environment where the temperature changes a lot of variation in temperature, what might happen? Expansion and contraction. Now, do you think that glass and the plastic buffer material expand and contract at the same rate? No, they don't. So if I put a tight buffer cable in an outside plant environment and it's exposed to a lot of temperature variation, I can have broken glass all through that fiber. Okay. So for outside plant, what we do is we take the core and the cladding and the 250 micron coated fibers, and we put it inside a buffer tube, a plastic tube, and they just rest in there, right? They're not attached to anything. And what that allows it to do is allows the plastic components of the cable assembly to expand and contract on their own, and the glass to do it at its own rate so stuff doesn't break. Right? That's known as loose tube. Loose tube or outside plant cable. Okay. In-building cable, we're going to have that 900 micron buffer tight around the fiber because we're not worried about expansion and contraction. It makes it a lot easier for us to work with. That's the main difference between outside plant and inside plant, along with the makeup of the jacketing material. If it's got to be, you know, UV resistant and waterproof and all that other stuff. As far as cable types, there's a myriad of different types. You can have single fiber zip cord or dual fiber zip cord, LAN cables, which just basically have two strands that are in their single jacket, distribution cables. You get the idea there. All right, now we'll talk about connectors. And yes?
Do you have any issues with it becoming brittle over time?
No.
Even with expansion and contraction?
No, if it's a loose tube type of cable that's designed for outside plant use, the only issue you can have is if the sheath, it can't get wet, right? It's not supposed to get wet, it's not supposed to be exposed to prolonged moisture. That can actually affect the integrity of the coating, which if it does, will affect the integrity of the glass. But outside plant cable that's in a proper environment and doesn't get wet, it can expand and contract a long time. There's stuff in the ground and in the air that the phone company put in the mid-80s, and it's fine.
Is there a protective gel in that loose tube?
There can or cannot be.
Cannot mean that it's not supposed
No,
to be there.
you can get it. You can get gel fill cables, or you can get cables that are not gel fill.
What's the advantage of the gel fill?
Gel fill keeps water out. If there's potential for, if there is potential for water incursion, and you want to be certain that it doesn't get in there, then you use a gel fill. Problem with that is when you bring a gel fill cable into the building, it's no fun.
Mm-hmm.
You can keep it an outside plant, it's okay. You bring it in the building, yeah.
Well, I think there's a regulation that you can only take 50 feet of the outdoor cable into the building.
There is, and that has to do with the makeup of the sheath of the cable. If it's not rated for in-building, it can burn and have really bad toxins.
Mhm.
So if it's an outside plant cable with a sheath that is basically polyethylene, yes, within 50 feet, you got to change it to something else.